Why did this speak on? So we sort of left off in class when we were talking about the fact that sodium has 1 valence electron and chlorine has 7 valence electrons. That the sodium will give its electron to the chlorine, thereby making each of these ions, the sodium being a positive ion, the chloride being a negative ion, and together as sodium chloride, they are forming what is called an ionic bond. And again, that is a bond between a metal and a nonmetal. And again, we're excuse me, we're like applying some ideas to electrons just to make it easier for us to understand that sodium gives up the chloride. And again, when they give up those electrons, both the sodium and the chlorine get to have a complete octet. Now, electrons don't always just give up, or atoms don't always just give up electrons. It really depends on what type of atom it is. If we're dealing with nonmetal atoms will often share electrons. So let's look at hydrogen, for example. So hydrogen, a single hydrogen, has 1 valence electron. And since hydrogen is the one of the exceptions to the octet rule, and it would prefer to have a full outer shell with 2 electrons, right, it would be very happy to join up with just another hydrogen and thereby sharing their 2 electrons and then forming what we would call a molecule of hydrogen. And that is done by sharing the electrons, and that would create a covalent bond. Okay, another example is hydrogen with its 1 electron, perhaps coming across a chlorine with its 7 valence electrons. And so again, by sharing their electrons, the chlorine gets it's an octet of electrons, the hydrogen gets its 2 electrons, and again we have what is a covalent bond between hydrogen and chlorine, HCl. Now, that's pretty easy, pretty straightforward, hopefully. What you may need to do when we get into some more complex, if we start talking about a bond between carbon and oxygen, you may have to follow a couple steps here. So oxygen has 6 valence electrons. Okay. Carbon has 4 valence electrons. And so what happens is if carbon and oxygen share 2 of their electrons each, that's great for the oxygen because the oxygen gets its octet. It's 8 electrons around it because we can count these shared electrons for the oxygen. But carbon, still has only 6 electrons around it. So it needs to gain more. So it actually needs another oxygen. And so we need to have 2 oxygens per 1 carbon in that case to get to that covalent molecule. Here's one more example. Say we're dealing with fluorine. Fluorine has 7 valence electrons. It is only 1 shy of an octet. So it might come across another fluorine with, again, 7 valence electrons. And what can happen is those fluorines can share those electrons, and what we end up with is a molecule of fluorine, which is a covalent bond, just like the carbon dioxide is a covalent bond. So covalent bonds, two nonmetals sharing electrons is a typical way that is described, although it is much more complex than that. And when we have a metal and a nonmetal, sodium and chlorine, that would be a ionic bond, where we, again, take something very complex and say the sodium gives up the electron to chlorine. So hopefully you understand that. We'll talk more about that in class. We'll see you. Is if we're talking about a another type of atom,